In this lab, we're going to do an introduction to programming with Julia. Now, we already have a code script ready, which we are about to use. But before doing so, let's just click on it to see how our Atom interface looks like. Now we have two main windows that we will be using. The first one is this one, which actually contains our script, our code. And the second one is the REPL, read, evaluate, print loop. This is the console. Now here, we just have to press enter for Julia to start. We can see that there are two other windows that we might want to use. Now, the first one is this, called the project panel, where we can choose to add folders and see some actual scripts from a folder in our computer, which is relatively useful if you want to close and open many files once again. But otherwise, you can just close this window and reopen it using this arrow here. Now the last one is the workspace. This is where we will be seeing all the variables that we are about to store in Julia, but for the time being we are not concerned with this window in particular. Now you can see here that this Julia with the right looking arrow appears, and this means that we can insert a certain line of code here and execute it. Now this is not really convenient in programming. We prefer to use a script which we can save and send to a friend or a colleague. Now it's time to begin our introduction, and a few basic key points before we start is that there are two types of line in a script. Those that start with a hashtag are the comments. That means that these lines are referring to humans, and Julia will not be executing any code in these lines. The lines that do not start with a hashtag are actual code, and Julia will try to execute them. So first of all, you can use Julia as a calculator. Now, in order to execute this line right here, I can press my control button plus enter, and the result will appear next to the line of code. Now I can do exactly the same here in my console and type 3 plus 6, press enter, and the result will appear here. Now it's easy to evaluate simple mathematical expressions in Julia to basically use Julia as a calculator, but we can also type more complex numerical expressions like the one seen here. Now always remember that you want to use parentheses to prioritize certain expressions, and Julia will actually evaluate them exactly as in math. Now, as in math, we may want to omit the multiplication sign, but in Julia we can only do so like here when we have a coefficient. Now in this example, Julia will actually print the same result, but if we try to multiply two complex expressions and not a coefficient, Julia will actually throw an error message. So it's considered best practice to always use the multiplication sign, so no problems occur. Now, what we want to do when we're actually programming something is store things inside objects. Here we can see that we we define a variable called x, which holds to the value 3. Now, if I type Control plus Enter, I can see that x is actually stored in memory, and it also appears here on my Workspace panel. Now we also see a few different things stored here, but these will not be concerning us for the time being. So uh, we only focus here on this object x, which stores the value 3. Now you can see that the result also appears next to our line of code, and if we want to omit this result, we can use a semicolon. So here we just get a check mark, but once again Julia stores our variable just like before. So uh, let's say that we do not have our workspace here. How can we actually see the value stored inside x? We can either go here in our console, type x and press enter, and we will see our value, or do the same here on our script and get the value 3. Now we can use variables exactly as numbers in a numerical expression. So x plus 5 equals 8. Now something that we want to keep in mind is that we can use variables to declare other variables. So here we define y to be 2 plus 2, that is 4, and then we define z to be the sum of x and y. We can see that every time I press Control up and enter, the new variables appear here on my workspace. Now, what's going to happen if I change the value of x? Will the value of z change accordingly or not? Let's try it out. So let's say that x now is equal to 1. We can see that here, or again in the console, or in our workspace right here. Z remains keeps its old value 7. That is z is stored in independent memory space from x. So changing x does not change z, even though z was defined using x, and that is something we want to keep in mind. Now we can use these two expressions to alter the value of an object. So um, the the long format is x is equal to x plus 2. Watch out here, this is not actually the equality sign used in math. This is not an equation. X gets the value that x has currently stored inside plus 2. That means the value of x is increased by 2. If this format confuses us, we can use this format that is typical in other languages like C++. So if I execute this line of code, x will get the value of 3 once again, and if I execute the next line, x will increase by 2 more. So now we can see that x equals 5. Moving on to variable names, we can use words or even phrases for variable names, but we have to keep in mind that it is the best practice to keep our names short and clear. So here I define a new variable called the year that holds the value of 2000, and here I define the variable last underscore year. If I want to give a name that consists of more than one word, I have to separate the two words with an underscore, or just type them as a single word. What I want to keep in mind is that long names are hardly any convenient in programming, as well as weird acronyms. So this acronym here, Year of New Millennium, is not clear and should be avoided. Now, both these names might be inconvenient, but there's nothing wrong with them. They are accepted by Julia. But these two here will throw an error message, and that's because here it's two separate words which we cannot do in Julia, and this this name here uses a dot instead of an underscore to separate the two words. None of these two can be done in Julia. So something fun and sometimes very convenient in Julia is that we may use Unicode characters as variable names. This includes the Greek alphabet as well as emojis. So in order to do so, we type the backward slash and start typing our Unicode character. So if it's a Greek letter, we can use its full name like delta and press the tab button. So you can see here that the Greek letter delta actually appears. Now we can do this with several signs as well. For example, I can type for all, press the tab button, and the for all symbol appears. Now, if I want to type in an emoji, I can just tap the backward slash once again, uh, and type the name of the emoji that I want inserted between these two lower and upper dot signs. So let's try cat, for example, and press the tab button. You can see that our cat appears here. So I can use all of these Unicode characters as variable names in Julia. You can see that all of these lines are executed normally, and the value names appear here along with their values. Now, a few more things before we conclude this lab. Let's assume that we do not have the workspace panel here. How can we see every variable that's stored in Julia? Now, there's a very useful function called var info, which uh, prints a very neat table here along with all of our variables. Now, uh, if we want to delete a certain variable, we actually have a workaround in Julia. So we cannot remove a namespace from Julia once it's declared. That means there is no possible way to delete any of these variables now that they are defined. But in case that we want to clear, empty one variable, we can actually do that and save memory space on our machine. So there is one certain keyword that we want to keep in mind, and that is nothing. I can use nothing to, as a value to store inside a variable and save a lot of memory space from in my machine. So if you're used to store a large matrix of around 2 megabyte, I would want to empty that variable name, and that can be done using nothing. So we can see here that here stores the value nothing inside. Now, um, something concerning this file here, this script, every single script in Julia ends with a suffix .jl. So we can actually go to a file and open a new file or save a file that ends in .jl and use it exactly as we're doing right now. Now, uh, if we want to clear our console, we can go here down in the console and type Control plus L, and we can see here that we get a new window here in the console that's clean and Even though we do not want to use our console all the time, sometimes it will be useful. So keep in mind that by pressing Control plus L, you get to clear your console. Now you can just scroll up again and see that the Julia sign is still here, but you get a free console whatsoever. So before we conclude, one final note that you might find in Handy is how to create a code cell, that is a certain chunk of code that you can execute altogether. Now, we can do this using the symbol sequence of a double hashtag, or a hashtag followed by three dashes, or a hashtag followed by 2 times the percentage sign. So if I place my cursor inside a code cell, I can type Alt plus Enter instead of Control plus Enter, and execute the whole cell in once. Now, you can see that K and L are actually stored here, and I can repeat the same procedure, Alt plus Enter, to save M and N, or O and P. So this concludes our introduction in Julia and Atom IDE.